The visibility to migrate with success. Getting wire data when there are no wires. This is what I've been leading up to, but let's rewind a bit. What is wire data, and why does wire data matter? Then you'll realize why you need it. The good news about applications, whether multi-tiered, microservice, or monolithic, they need to communicate with the users and with themselves. They do that over the network, and most commonly over TCP/IP. That's packet data, also known as wire data. Packet data is an incredibly rich source of data, the single source of truth. Every interaction of applications and users, user experience and performance is underpinned by traffic on the network. Think about it. When I make a request to my CRM system, I'm probably talking through a web browser, to a web server, probably through a load balancer, to app servers, to microservices, containers, databases, middleware, authentication servers, and also to other shared services such as DNS. All of those make up the service chain and ultimately define my user experience. Any one of those components could be at the root cause of any performance issue, which means that packet data can tell me where the problem is. The bad news is that packet data is notoriously difficult to interpret. It's unstructured and there's a ton of it. In a moment, I'll tell you about a new approach, the NETSCOUT way of continuous monitoring of applications using packet data, which comes into its own when translated into meaningful, structured, key performance indicators or smart data. But in the meantime, the complexities of managing packet data has resulted in a multitude of approaches for performance monitoring that rely on other points of instrumentation. NetFlow. This is just a summarization of the packet data, providing flow information, X talking to Y, with so much data on such and such an application. There can be a huge amount of net flow in a network, and generating it places a burden on the routers and switches generating it. The resulting data collected and analyzed is good for capacity management data, but doesn't really tell you anything about the performance of the application. And when it's coming to forensics, there's nothing to drill down to. Logs. All applications generate logs. Servers generate logs too. There's lots of them. So you would think that you could look at logs and then you could make sense as to what's going on in your application. Yes, but logs have no structure, and you gather them for every machine, every service, every application to a central store, and then must do complex logic to try and correlate this into any meaningful service view, if that's even possible. Another thing is, how do you get performance information from logs anyway? How fast the server is responding? Is it slow because of the network or the application? You just can't do that with logs. Infrastructure performance, CPU, memory utilization, disk I/O, network I/O, on routers and switches and servers. Again, information readily available by polling the infrastructure, storing and analyzing the results, and coming up with some metrics. Nice, but when you consider things, none of this information tells you that the service is performing badly. Or well, yes, my CPU is running hot. I'm running out of memory, but that may all be normal and my application is still running fine. You just don't know. Application code instrumentation. If the logs don't give you enough information, then you can implement performance code or agents in your applications to register the application performance. Awesome. This is great for developers, developing applications, debugging code, optimizing code. The agent is part of the code, so this methodology only works for specific code frameworks, Java, .NET, PHP, Node.js, etc. And they only see what the application code is doing. Consequently, have a narrow view. When you place the application into production, these agents struggle to see other dependencies in the environment that's installed into, and scaling this up into production often gets real expensive. So deployment is typically deployed in only a few applications. All these above approaches, though commonly deployed today, are limited by what they can see, the specific logs, specific applications, server performance, but not how everything is linked together and the performance of the service. So back to wire data and why it's important. Well, it's everywhere, private and public clouds, and it's how applications communicate. NETSCOUT has developed a software solution to harness the rich information derived from wire data. It generates meaningful performance metrics, both network and application performance, latency and errors, and security insights of all applications running in the network. We call this smart data and provides visibility on-prem data centers, on bare metal servers, in the private data center, the SDDC, colo, or in the public cloud, in containers, in pods, whatever you've deployed. This is what we call visibility without borders. This NETSCOUT patented technology, called Adaptive Service Intelligence, or ASI for short, provides meaningful key performance metrics out of packet data and stores, indexes the sessions and packets for packet forensics after the KPIs have done their job. Long gone are the days when you need to sift through gigabytes of packets of data. ASI understands the relationships of one component to another, user to application to microservice to database, and builds or discovers the services in the chain. If there is a performance issue, ASI sees the database, the web server, the app, the microservice, the shared service, the enabler. That's the root cause. Remember, these application components could be distributed across different environments, on-prem or in the clouds. ASI works the same everywhere because wire data is everywhere. ASI data can be used to optimize application performance, say seeing the difference of the performance with a cloud-hosted database versus one on-prem, or a colo-based web server versus one in IaaS. One other thought, this service dependency modeling can be used to understand the application components pre-migration. Remember the documentation issue I had in an earlier video? Huge! So what's the catch with wire data? Which leads me back to, how do you get wire data when there are no wires? What I mean is, traditional data center model has either bare metal servers or hosts connected to top-of-rack switches, and you could either span or tap the wires, the physical wires, to see what's going on. What that is north-south communications. The trouble is, in the private and public clouds, the modern data center, most of the data is east-west. Virtualization means that you have multiple machines connected inside a host, VMware ESX, NSX, KVM, and also in the public cloud. Everything amounts to east-west traffic. You can't even get at the wires. Same in container environments, with virtualization within virtual environments. However, all that said, there's more good news for you. We can get wire data when there are no wires. NETSCOUT can be deployed in virtual machines as part of the guest operating system, seeing the wire data going in and out of the VMs. That's east-west in the cloud. And then calculates the ASI KPIs in real time, giving valuable insights into anything that the VM is talking to. Secondly, NETSCOUT have partnered with key cloud vendors, AWS and Azure, to take advantage of the Amazon VPC traffic mirroring and Azure virtual tap functionality, which allows virtual machines to have their traffic copied to the monitoring solution. ASI then translate this mirrored traffic to KPIs, this time without the overhead of installing agents on the individual VMs, with the added bonus that traffic mirroring orchestration is done at the cloud infrastructure level. So, NETSCOUT has solved the problem for accessing and storing wire data efficiently in the cloud. It's solved the problem of cost, as it is software, and scalable to the largest of networks and virtual cloud environments. ASI has solved the problem of needing to sift through gigabytes of packets to get to performance issues and the root cause and reduce troubleshooting times. ASI translates complex packet data into meaningful performance and dependency and security insights to provide evidence much quicker than ever before, and visibility of everything that the application is communicating wherever it resides. NETSCOUT gives you the information you need to successfully migrate to the cloud or multi-cloud with confidence. So there it is, cloud migration theory wrapped up. The why, the where, the which, the how, and the visibility required. Next, we'll take a look at how all of this has been put into practice.